Okay, let's jump in. Today we are doing a deep dive on a really serious piece of video infrastructure. It's the NTI SM-32X32-DVI-LCD-5V16A DVI video matrix switch. That model number is a real mouthful, but what it does is huge.
It really is. Our mission here is to get past the spec sheet
Mm.
and really understand the scale of this thing. I mean, we're talking about environments like, huge security command centers, places that need to route video from dozens of sources to dozens of displays all at once without a single glitch.
And that 32 by 32 number is the key. 32 single-link DVI inputs, the 32 outputs, the complexity there, it just grows exponentially.
It does. And what's interesting is how they let you control it. You're not locked into one method. You can use the front panel buttons, sure.
The old school way.
Exactly. But you can also control it over Ethernet or an RS-232 serial port. That kind of flexibility is, well, it's essential for any large-scale professional setup.
Right. And then there's the video performance side, which gets pretty interesting. It handles your standard HDTV resolutions, up to 1080p, but also computer resolutions up to 1920 by 1200.
WUXGA. And for anyone who works with professional monitors, that extra vertical space is critical. Supporting that many different resolutions means you have to manage the handshake between the source and the display.
Which is where EDID comes in, right?
That's it exactly. EDID, it stands for Extended Display Identification Data. It's basically the display telling the source what it can handle. If that fails in a 32 by 32 matrix, you have chaos. So this switch can learn the EDID from any display. And it even has default tables for PC and Mac just in case. It just works.
Plus, it's not stuck in the past. Even though it's a DVI switch, it can pass HDMI audio and video through its DVI-I port. You just need the right cable.
But the real genius, the absolute game changer for this specific model, is hidden right in the name, the tiny 5V16A.
Okay, so let's break that down. What does that actually mean?
It means this unit has internal 5-volt power supplies built right into the output card. And you might ask, why would they do that?
That's the logistical masterstroke. Those power supplies are there to power connected fiber optic extenders remotely.
Exactly. If you're running a DDI signal over fiber for, say, thousands of feet, and this can go up to nearly 5,000 feet, you suddenly have a huge power problem at the other end.
You'd need 32 separate power outlets for 32 extenders up in ceilings, on poles, just everywhere. It's a nightmare.
And this switch just eliminates that. It sends the power right to the extender unit, 32 fewer power bricks to worry about. That is why this thing costs over $6,000. You're buying simplicity and reliability at scale.
Okay, but speaking of scale, there has to be a trade-off. What's the main limitation here?
There's one big one,
Yeah.
HDCP, the copy protection.
It's not supported.
Well, it's not supported when you connect one input to multiple outputs. It's a performance trade-off.
Yeah.
Managing all those encryption handshakes for multicasting is just too much processing overhead at this scale.
So to wrap this up for you, what we have here isn't just some simple switch. It's a high reliability command center component. It's built for massive scale, and it solves a huge logistical problem with that integrated remote power.
Precisely. And that HDCP limitation actually tells you who this is for. It's perfect for environments where the video feeds are vital, but not commercially copy protected. Think air traffic control, security camera walls, process monitoring in a factory. So given that it has an MTBF, a mean time between failures, of over 35,000 hours, it raises a question. What critical non-commercial video feed would you trust to this level of specialized reliable hardware? That's what this technology makes you think about.